Hey, class. Oh, of course. Sorry. Okay, so we are on part 2 of Unit 18, and we're on number 11, and we're just doing the review so that you understand the problems and how to do them for when you take the test. Anyway, number 11, find the angle of depression from the top of a lighthouse 275 feet above water to a boat 1,324 feet offshore. All right, so we have a lighthouse, and I'm usually not very good at lighthouses, but anyway, there's our lighthouse. And from the top, we have an angle of depression that is what we're looking for. We don't know what it is. And it's 275 feet above water. So this is our 275 feet. And then to a boat, I'm always the best at drawing boats. Anyway, there's the water. And the boat is 1,324 feet off of shore. All right, so here's the shoreline with the lighthouse on it. So what we're looking for is this angle of depression from the top of the lighthouse. That angle of depression is not inside of the triangle that we are using, and we need to get it inside of the triangle that we are using, and we use alternate interior angles in order to do that. So we'll have to move the angle inside of our triangle using alternate interior angles. And if this is the angle we want, we have opposite and adjacent, which is tangent.
I will page you back on your phone extension and let you know what you decided.
Sorry. All right, so tan inverse of the opposite over the adjacent, because TOA. So opposite is 275 and adjacent is 1,324 feet. So that will allow us to find the angle. So in our calculator, we'll do second tan to get the inverse. 275 divide 1,324, and that is 11.7 degrees, approximately. So that will be your angle of elevation. All right, number 12, Michaela is standing directly between a 90-foot tall courthouse and a 54-foot tall bank. If the angle of elevation from the point where Michaela is standing to the top of the courthouse is 72, while the angle of elevation to the top of the bank is 35 degrees, what is the distance between the courthouse and the bank? All right, so this is going to be kind of a difficult problem. So here's our courthouse. I don't know how to draw a courthouse, but all right, there it is. Okay, and then we have a bank over here. All right, so Michaela, somewhere in between. So I'll have to draw Michaela there. Okay, give her here. So. All right, the angle of elevation from the point where Michaela is standing to the top of the courthouse, right here, is 72 degrees from the point to the top. While the angle of elevation to the top of the bank is 35 degrees, what is the distance between the courthouse and the bank? So let me do that in a different color. So from here to here, we want to know this total distance. All right? And then we know that this is 90 feet tall, the courthouse, and 54 feet tall for the bank. All right, so what we need to do is we need to find this side. We'll call it X, and this side, we'll call it Y, and we need to add them two together to get the total distance. All right, so to solve for X, we have a tangent because we have opposite and adjacent. So tangent of 72 degrees is equal to 90 over X. We're going to switcheroo. X is 90 over tan 72. And so 90 divide tan 72 is 29.2 feet. All right, then to find Y, right here, this Y, we have, again, a tangent because we have opposite and adjacent from that angle. Tan 35 degrees is equal to the 54 feet over Y. the distance between where Michaela is standing and to the bank. Again, it's a switch because y is on the denominator, so y is 54 over tan 35. So 54 divide tan 35, and that is 77.1 feet. And if we take those, and I'm just going to extract them using my return button and add them together, enter, I get this total distance of 106.4 feet. That's how far apart the bank is from the courthouse. All right, and that concludes our review. So run through the review with me, make sure you know how to do all the problems, and then take the test. Hope you have a great day.